picture. Because you messed me up, I get a request from you and to help you. Thank you.
Okay, look up. Okay, look at me, please. Look at me. Okay, 37 I'm going to do very quickly. I just want you to watch. And I want you to remember a little phrase here. I tried to make it creative, and it's kind of creative, but you need to work on it a little bit. If you're solving a limit problem and you forget to factor, be prepared to fail. What? You're solving a limit problem, you forget to factor, you're going to fail. Here's the problem already laid out in 37. So first thing I notice is, to find this limit, I need to factor this.
Oh, that's probably what I did wrong.
So I did. If you forget to factor, you are going to fail. Question. Once I factor, I notice that this portion here is equivalent to 1, as long as x isn't equal to a. But because I'm finding a limit, I don't care about x equaling a. I'm only going to worry about x being a little less than a or x being a little more than a. So this will be equal to 1. Question. That means I'm finding the limit of this, which is much simpler. Now when I plug in a little less than 1 or a little more than 1, in both cases I get the same result. This was somebody else's question here, so don't worry about that. Therefore, the overall limit is 1 over 2a squared. Okay. Be prepared to encounter limit problems on the test I'll give you that require you to remember these things. You must factor first. You must plug in a little less, a little more. Question.
How did you get from 1 over x squared plus a to 1 over 2a squared?
So I plug in an x value that is slightly less than a and slightly more than a. You see it now?
Oh, okay. Yeah.
Good question. Next one. Okay, 38. Once again, in 38, they're testing your knowledge of the fact that when they are referring to a horizontal asymptote, they don't use the word horizontal asymptote, but that's what that statement means. The horizontal line is an asymptote, therefore it is a horizontal asymptote. They're expecting you to remember what we've already talked about. You have a function. The function's y value will get very close to 2 eventually. So eventually the graph will do something like this. But what happens over here is irrelevant. And they're going to ask you a bunch of questions to see if you really understand how irrelevant this actually is. So someone raise your hand, pick up some tickets. Just tell me how to draw that information over here. Go ahead. Go, Oakland.
When a misses f is 0, then equal to 2, so it should be like a dot.
Very good. So go to x equals 0, y equal 2, and I place a dot. Follow-up question 2 for Oakley. Okay. If the function has a horizontal asymptote, is there any requirement that there be a point on the function right here? No, it has nothing to do with the horizontal asymptote. There could be a point here, there might not be a point there. It simply has nothing to do with the horizontal asymptote. Question? Go to the next one. Somebody raise your hand and interpret this for me. Tell me what that means in English. That's the math statement. What is the English version? Heidi.
X is not, well, f of x is not equal to 2 when x is greater than 0.
So if I look at the graph, Heidi says I go for x greater than 0, which is all of this space. Heidi, the symbol f of x, when we're talking about a function, we're always talking about x or y coordinates. Which one does that one represent in this case?
X.
2 tickets, we're going to try the common mistake.
Okay.
The f of x really represents the y. It doesn't matter. So f of x is the y, so it's telling you the y coordinate will never be 2. So they're saying if you plotted points, you'll never have a point that is on this line. Again, that has nothing to do with the horizontal asymptote. The graph could easily do this and hit that y equal 2 line many, many times, and then simply eventually get close to 2. Follow-up question. So keep in mind, the horizontal asymptotes were the most missed in the past few years. So I'm trying to find ways to get you to understand it a little bit better. So, awesome. F of 2 is undefined. That means we look over here at x equal 2. F of 2 means the y coordinate. So they're saying at x equal 2, you will not find a y coordinate. It's irrelevant. It has nothing to do with the horizontal asymptote. Maybe you won't find one, maybe you will. I don't know. Questions? The last one says that, let's see, as x approaches 2, the limit will be infinity. So at x equals 2, when we get very, very close, we'll find a y coordinate that is very, very positive. You could, that could happen. It simply is unrelated to the horizontal asymptote. Follow-up questions. Last one. This is the definition of a horizontal asymptote. That's exactly what horizontal asymptote means. That as x gets close to infinity, the y value gets close to 2. Questions? Good work, good focus. Next one. So E is the correct answer.
So can you go to the B part again? The B.
Part B?
Yeah. Okay.
I'll ask you some questions that will make it stick in your memory better.
Okay.
So the symbol f of x, Jeff, what does the symbol f of x represent?
The X equals
Same mistake as height, it means the y. No worries. So it's saying the y coordinate will never be 2. Y coordinate is never 2. So if you were looking at the function, you would say, oh, none of the y values are ever 2. But that has nothing to do with the horizontal asymptote. You could have a function where there were no y values that are equal to 2. You could have one there were many of them are equal to 2. It just has nothing to do with the horizontal asymptote. Good. Hopefully.
So for D, would it only must be true if there was a hole at x equals 2 or something?
D is actually referring to a vertical asymptote.
Okay.
They're saying if you get close to x equal 2, the y value gets close to infinity. So you have a feature like this, which, those are pretty good lines for him, though. Which is definitely possible. You can have a function that has a vertical asymptote at 2, and then also a horizontal asymptote at y equal 2. They're just unrelated. Yeah. Knowing this doesn't tell me that.
Okay.
Please.
So just all the other answers are just real relevant to
Perfect. Yeah, these are, all of these statements could be true, or they could be false. They're just unrelated to a horizontal asymptote. Hey, it's a good example of what you will see on my test. AP test writers are very good at writing questions that don't just test one idea. This problem is testing a whole bunch of ideas. You've got to be able to read each part of it and understand what they're saying. Other questions? Awesome. Next one. Okay, 42 we're going to skip for now. We did one that was very similar just a minute ago. This one here. 37 and 42 are solved in almost exactly the same way. I'm going to let you work on that yourself for a minute. You simply need to factor first. Factor first, the problem becomes fairly straightforward. Still need help from talking to Jackson.
I just have a question, but what does it mean by the limit exists?
Oh, thank you. Good follow-up. So let me just jump ahead for a second. If I factor, what I get is the following. This piece can factor like this. So let's go x plus a, x minus a, all divided by x minus a. So this divides to make 1. Meaning our function really is simply x plus a for all values of x except a, and then our function is 0 for when x is a. Is everyone comfortable to hear?
Yes.
Okay. I'd like somebody to explain this. I'll pay you multiple tickets depending on how good your explanation is. They started the problem by saying this is f of x. I'm saying this is f of x. They're perfectly equivalent. This is equal to 1, but there is an exception. Somebody raise your hand and tell me, what is the exception? What value of x is this no longer equal to 1? Mikkel. A. If we plug in x equal a, Mikkel, what does this equal? 0 divided by 0, which is what? Undefined. 2 points for Mikkel. However, you're never supposed to plug in a anyway, so it doesn't matter. So the exception is irrelevant. Questions? Please, Chuck.
You said that it would make it undefined, just like not actually the problem, but if it made it undefined, would that just automatically make the whole problem undefined as well?
Oh, good question. No, it simply means that the function's value, when x is equal, this is 3 points, Chad, it's very good. When x is equal to a, we wouldn't know the value, we wouldn't know what it is. But the rest of the problem could possibly be solved.
Okay.
So,
You could know a little more and a little less.
yes, you could know perhaps a little less and a little more. The only thing you wouldn't know is what's happening at a.
Yeah.
Good question. So raise that, it's different. Is everybody good to hear? Okay, now here's Jackson's question. It says, does the limit exist? That's just another way of saying, please go find the limit. So I go plug in a little more and a little less than a, and I get exactly a limit that's equal to 2a, a little more, I end up with a limit that is also equal to 2a. Therefore, the limit does exist, and it's equal to a value of 2a. That's what's meant by exist. If we had found these to be different, Jackson, then we'd say the limit does not exist. Does that answer your question? Good. Anyone else have a follow-up on this one? I'm going to give Jackson 2 more, because what you did is crucial. You didn't let yourself kind of just let the problem go by and say, well, I don't really know what exists means, maybe it won't ever come up again. It always comes up, for sure. Like on the AP test, my test, they just keep going around and around, they'll come back and get you, so it's a good question. Please.
So it doesn't exist if they're not complete.
Right, if the left limit and the right limit are different, then the overall limit does not exist. Perfect. It actually relates to Chad's question as well, because for this problem, we still have this kind of exception here, but it had nothing to do with it, because it's just the left and the right. Other questions? Next one. Well, we didn't finish. We know this one is true. Okay, somebody comment on that.
So we know that f of a does exist because it says in the b special for x equals a and then n.
Nicely done, Oakley. F of a exists because it tells us when x is equal to a, the y coordinate is 0. That means f of a is equal to 0. That's a true statement. It definitely exists. It says, is the function continuous at x equal a? The function is not continuous because the 3 y coordinates are not infinitesimally close to each other. There's a y coordinate of 2a, goes back to 0, back up to 2a. Other follow-up questions? All right. 42. Okay, we're going to skip 46. 46 is nearly an exact copy of the problem we just did. Please So, hey, don't talk to me. Sarah, what's the simple definition I gave you for what a function is?
X and Y.
List of x, y pairs. Okay, so Sarah, the list is the definition. And so if f of x, again, Sarah, what does the f of x really represent? The y coordinate. So when we get to x equal 2, as long as we find some y coordinate, which in this case will be 1, then we know that the function is defined at x equal 2. If this were unknown, Sarah, then we would say the function is not defined at x equals 2. Does that answer your question?
Yeah.
Good. Anyone else? Okay. So we'll skip 46. 47. Come back to 43, perhaps. We're going to do 43 instead of 47 because it's a better problem. Once again, the AP test writers are good at testing you on multiple concepts from one problem. To solve this problem, you must know what this means. The limit as x approaches b exists. You must also know what it means for a function to be not continuous at b. That means the b they're referring to are different x coordinates. We're looking at b equals -1, 0, 1, 2, and 3. We're supposed to look at those 5 spots and identify if the function is not continuous, and also to identify if the function's limit exists at those points. At only one point will both things happen. Okay. This is a very common way to ask an AP question. Does anyone have any kind of follow-up question regarding kind of how it's being asked? Awesome. So I think the easy one is the blue one. So identify first of all at which of the 5 is the function not continuous. Somebody. Ellie. Very good. We're looking for not continuous. So Ellie correctly said we're looking for a place where there's a hole, jump, vertical asymptote. Somebody jump in and help. Sarah.
It's not going to be a jump because, or a vertical asymptote because it says that it's continuous.
I asked the question poorly, so that was my bad. What we're looking for is we have this function, and we're specifically looking for a spot where the function is not continuous. So you tell me, Sarah, at which of these x coordinates is the function not continuous?
It's not like 2, 0,
Very good. So b could equal -1, 0, or 2, and the function would not be continuous. Make sense? Another question? So we don't need to look at the other values, which would be 1 or 3. Okay, next thing, we need to identify, does the limit exist? So starting here at -1, if I follow the function and get closer and closer to -1 from the positive side, what y value will I be approaching? So I'm going from the right-hand side, I'm getting closer and closer to an x coordinate of -1, that's the limit I'm finding. What y value am I going to discover? Lots of different voices, positive infinity is the correct answer. As x approaches -1 from the right, the y value is approaching infinity. Can't see it, you just need to tell me you can't see it, we'll talk about it again. If I approach x equal -1 from this side, so I get closer and closer to x equal -1, what y coordinate am I getting closer and closer to? That's better, negative infinity. So the limit, as x approaches -1 from the left, is negative infinity. So what is the limit as x approaches -1 in general. Does not exist. Because the limit does not exist, that doesn't match the requirement. We're looking for a place where the limit does exist. Follow-up question. Okay. That's going to happen here. As you get closer and closer to x equals 0 from the left, the y-coordinate's close to 2. As you get closer and closer to x equals 0 from the right, the y-coordinate is still 2. That makes the correct answer B. Follow-up questions? Okay, awesome. You're going to make a list in your notebook. There's no homework tonight. This was our first exposure to AP questions. So it just takes a while to kind of get used to the idea of really understanding all parts of it. No homework tonight. But you want to get started on a list of definitions, terms, expressions, symbols that we will discuss more fully next time. Here's the list. You'll need to memorize everything that we write down. You have talked about slope for many years. In our class, we will try to avoid saying just slope because there's two kinds of slope you have to keep track of. There is what's known as the secant slope, and there's what's known as the tangent slope. Write both of those down, please. Secant slope and tangent slope. I'm going to watch your writing so I don't go too fast. So we have to know the secant slope and the tangent slope and keep them separate. Related but similar ideas. Okay, secant slope is what you have studied for years and years. It's the slope between 2 points. So prior to calculus, you thought of that as just being slope. Slope between 2 points. Again, we can't think of it as just slope any longer because we studied tangent slope as well. In fact, until December, like basically the end of semester 1, the end of term 2, this is our focus, studying the tangent slope. And then we throw this in once in a while just to make sure we don't forget what secant slope means. Secant slope, slope between 2 points. Tangent slope, slope at a point. Any questions come to mind, feel free to ask. So this is mostly just getting the idea, but Landon, please.
Aren't they basically the same thing? Because like tangent slope is kind of just like going infinitesimally to the right and left of a point and finding the slope there.
3 points. It's very good.
Wow.
Tangent slope is technically the slope at a point, but how we end up finding it is what you said.
Yeah.
You're actually finding the slope between 2 points. They just happen to be infinitesimally close. But it is really the slope at a single point. That's a good question. Anyone else? Okay. Another name for this. You've heard this before. You got to memorize it. This is also known as the average rate of change. Average rate of change. I just spelled that wrong. Sorry. Average rate of change. And I get a little tired of writing average rate of change, so I came up with an abbreviation. This is just my invention. Somebody else probably does the same thing, but this just makes taking notes a little easier. Average rate of change. On the AP test, I've never seen this used. They'll spell it out in words. But for taking notes, this is okay. Questions? This one, by comparison, is known as the instantaneous rate of change. And spell instant. There we go. Rate of change. Did I spell it right? I'm like, I don't know. Question. And again, I'll write it like this to save ink, which is totally unnecessary when you're writing on an electronic whiteboard, but you know, whatever. Questions? Perfect. You need to know how to calculate this. You've calculated it before. Somebody earned some tickets. Raise your hand and tell me what is one way to compute the average rate of change. Sorry.
Rise over run.
Genius. What's another specific way to compute the rise over the run?
Okay, is it x2 minus x1 over y2 minus y1?
You're just upside down.
Okay, y2. Okay.
Yeah, the y coordinate is the rise, x coordinate is the rise.
Yeah.
Nicely done. Anyone remember any other notations for how to find the instantaneous rate of change? Sorry, average rate of change. This one shows up sometimes, delta y over delta x. This one also will show up. The value of the function of point B minus the value of the function of point A, all divided by B, subtract A. What? This is actually the most common. Like, you'll need to be most familiar with this. Remember, f of B simply means the y coordinate at one point, just like y2. This is the y coordinate at a different point, just like y1. So we have y2 minus y1, x2 minus x1. It's a different notation. Questions? Okay, over here, there are symbols as well. These will be new to most of you. F prime of x means the instantaneous rate of change of f. So that's a symbol to get used to. F prime. Prime is just an apostrophe, it's not a 1. You'll see it like this. D over dx of f means the same thing. It's related to this symbol. This means the instantaneous rate of change of the function with respect to x. Sometimes you'll see it like this, where they'll put the dA over dx out front, and the f after means the same thing. Sometimes you'll see it with parentheses, lots of different ways. We'll kind of figure it out for there next time. Good work. You're welcome. Well done. Jump reading.
Thank you. Had to figure out it for a second.
You don't need that for a moment.
Body had it. Grab those.
Jump in and you're welcome. See you guys.
It's so hard to stay focused. Thank you.
You're welcome. See you, parents.
Thank you, Mr. Smith.
Good job, Todd.
Thanks, Mr. Smith.
Good job, Braden.
Jackson, come on out. I'm not going.
Braden Bromley, please come to the main office. Braden Bromley, please come to the main office.
Good morning, Knights. This is Brian Bromley.
And Tara Bullington, please stand for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you, and here's Assistant Principal Mr. Keith.
Good morning, Knights. I am so happy to announce the results of our Homecoming Royalty primaries. These are the 4 finalists in each category that will be up for your vote at 12 p.m. Final voting for Homecoming Royalty begins today at noon and will close at 1 p.m., so right after lunch tomorrow. You can go to the Lone Peak website to vote. So congratulations to the following individuals. For Senior Queen, our finalists are Emma Hansen, Heather Winger, McKenna Flyler, and Noelle Filippi. Senior King, our finalists are Ammon Hanneman, Andrew Rice, Austin Kyler, and Chad Paskett. Junior Princess, our final contestants are McKenna Mason, Madeline Lambert, McKenna Eisinger, Rachel Neeleman. Our junior prince finalists are Bryson Thomas, Jacob Johnson, Max Brenchley, and Micah Haymuli. Our sophomore Duchess finalists are Daisha Rothwell, Daisy Schellenberg, Lauren Taylor, and Tyler Smith. And our sophomore Duke finalists are Logan Wells, Matthew Barney, Nathan Alstrom, and Zach Elzey. You can come meet these finalists in our homecoming lunchtime Fear Factor activity that will be going on in the Commons during lunch. Congratulations to all of our recommendations for the homecoming royalty, and the voting will begin again at noon today. Here is President Braden Romney. Your Geo Club is canceled due to parent-teacher conferences, so do not show up.
Do you need a little extra help in math? We provide free before and after school tutoring. For more info, ask your math teacher or check it out on the school website.
HOSA officer applications are due today. Send them in to Ms. Christensen, room 602, or Ms. Ross in room 135 today.
Attention all club presidents. If you would like to participate in this year's homecoming tailgate, come sign up in the front office.
Tonight we have our Lone Peak Powder Puff football game. It is at 7 o'clock and will be on the football field. Cost is $3 per person or $10 per family. There will be food trucks and concessions. Proceeds will go to the cheer team. So we'd love to see all of you there. It's going to be so much fun.
Magic the Gathering Club won't be meeting today due to parent-teacher conferences. And remember, guys,
This is our kingdom.